Mole calculations. First, I want to explain what is mole. Mole indicates a quantity. So for chemical substance, for 1 mole, just like that, the first definition considering Avogadro constant, the amount of substance that contains the Avogadro number of particles is called the mole. The Avogadro number is the constant value 6.02 10 to the power 23. So 1 mole equal to 6.02 10 to the power 23 of particles. Another definition considering RMM or RFM, the amount of substance that contains RFM or RMM amount of substance is called the mole. So 1 mole water is equal to 18 gram. That is, water has RMM 18 gram. So 18 gram water contains 1 mole. So I think you have got very little idea about the mole. But main concern is here calculation of moles. The formula of mole calculations, the first one, mole is equal to mass by MR. When mass is given in gram, we can convert directly to the mole dividing by MR or RMM or RFM, what we call it. Second formula, mole is equal to volume in dm cube divided by 24. This formula is used for calculation of mole, where the volume of gas is given at RTP. The volume of gas and RTP. The third formula for the solution, concentration and volume is given. We can find the mole directly using this formula. Mole is equal to concentration multiplied by volume. But we have to convert volume in dm cube. This is 1000 cm cube equal to 1 dm cube. Calculations in 2 ways. We can calculate moles in 2 ways. The first one, the preliminary or initial stage, directly using just formula. That second one, stoichiometric relation and the formula. The second one is very important. Mole calculation formula number 1, mole is equal to mass by MR. Already I told, mass given in gram. So if it is given in kg or given in ton, you have to convert it to the gram, then you have to divide by MR. The problem is here, sulfur dioxide and calcium carbonate. In this problem, you have to discover what data is given. Then what you have to calculate. Data given 960 tons of sulfur dioxide. That is mass given. We have to convert it to the gram. Here the clue is given. 1 ton is equal to 10 to the power 6 gram. So 960 multiplied by 10 to the power 6. This will be the mass of sulfur dioxide in gram divided by MR of sulfur dioxide 64. 32 plus 16 into 2. So we're getting mole of sulfur dioxide is 15 into 10 to the power 6 mole. Mole of calcium carbonate will be similar because the stoichiometric relation, 1:1. So mole of sulfur dioxide equal to the mole of calcium carbonate. It is very simple case. You have to complete the chemical equation. After that, you have to compare what data is given and which one you have to find out. You have to make the relation between these two. So the mass of calcium carbonate, mole into MR. The same formula, just I am writing different way. So mass is equal to mole into MR. Mole is 15 into 10 to the power 6, 15 millions, and the MR of calcium carbonate is quite easy, 100. So you are getting the gram. We are converting the gram to the ton. Another problem is phosphorus and phosphine. In this case, the mass of phosphorus is given. My suggestion, you find what data is given. Data given for the phosphorus 1.86. You have to convert it to the mole. Then you have to make the relation in the stoichiometric relation. Before that, you must ensure the equation is balanced. Phosphorus 4 and phosphine 1, pH 3, phosphine 1. So relation is 4:1. So mass of phosphine, you have to find out. For that one, you have to find out the mole of phosphine. So phosphine mole will be 1/4 of phosphorus. That is, we are dividing the mole of phosphorus by the 4, getting 0.15 mole. So mass of phosphine, mole into MR, mole multiplied by MR, that is 0.51. Mole calculation formula number 2. In this case, we'll use gas and RTP. The formula is mole is equal to volume in dm cube divided by 24. 1000 cm cube equal to 1 dm cube. You have to use this formula. Let's see. Nitrogen monoxide and carbon monoxide react in the catalytic converter, make nitrogen gas and carbon dioxide gas. In this case, volume of NO, that is nitrogen monoxide, is given 4.5 dm cube. So the formula we know, volume divided by 24, that is mole of nitrogen monoxide 0.1875 mole. So mole of nitrogen we have to find out. The ratio is 2:1. Mole of nitrogen will be just half of mole of nitrogen monoxide, that is 0.1875 0.875 divided by 2, this is 0.09375 mole. So volume of nitrogen multiplied by the 24, the same formula we are using, so 2.25 dm cube. Mole calculation formula 3, in this case we will use aqueous solution, and the formula mole is equal to concentration multiplied by volume. Volume should be in dm cube. The problem given here, calcium hydroxide and hydrochloric acid react, acid-base reaction. The ratio is 1:2. We'll use this, but before that you have to remember data given. What data is given here? The data given here, concentration of hydrochloric acid and the volume of hydrochloric acid. Volume given in 6 cm cube of hydrochloric acid. We have to convert it to the dm cube. And we have to multiply these two using this formula, mole is equal to concentration multiplied by volume. So you are getting 0.00009 mole. Mole of calcium hydroxide, just half of the mole of hydrochloric acid, because the ratio is given 1:2. Moles of hydrochloric acid is 2, mole of calcium hydroxide will be 1. So using this ratio we are finding the moles of calcium hydroxide. Volume of calcium hydroxide is given 20 cm cube. We have to convert it to the dm cube, that is 20 divided by 1000. We are getting 0.020. So mole divided by volume, we are getting the concentration of calcium hydroxide. Mole calculations for miscellaneous problems. Here the 3 formulas we can use more than one for one problem. So in this case, magnesium metal and sulfuric acid react. The ratio is 1:1. So data given, mass of magnesium metal, we are finding the moles using the formula mass by AR in this case, not MR, AR. This is the element, magnesium is the element. So 0.125 mole. The mole of sulfuric acid will be same because stoichiometric ratio is same, 1:1. If the mole of magnesium is 1, sulfuric acid is 1, so mole will be same. So mole of sulfuric acid equal to volume into concentration. Using this formula we can find out the volume. It is quite easy. The volume is 0.50. If you know this very simple mass, you can do it easily. Another miscellaneous problem, lithium metal and water. They to react and make lithium hydroxide and hydrogen gas, the equation is balanced. In this case, the data given, the mass of lithium 0.91 gram. My first suggestion was you have to find out what data is given, and then you have to discover what formula I have to use. So formula you have to know. The first formula, mass by AR of lithium is 7, you are getting 0.13 mole. So mole of hydrogen will be half of lithium, because ratio is 2:1. If the mole of lithium is 2, hydrogen will be 1. This ratio you have to use. This is very simple. We have to ensure the equation is balanced. So from this case you can find the mole of hydrogen 0.065, and volume of hydrogen, another formula we are using, mole into 24. The second formula we are using for this case, the volume of hydrogen is 1.56 dm cube. Another thing we have to find out, the concentration of lithium hydroxide. For this case, the mole of lithium hydroxide equal to the moles of lithium, because ratio is 2:2, that is same, 0.13 mole. So concentration of lithium is equal to mole divided by volume. Volume is given 0.25 dm cube. So the final answer, concentration of lithium hydroxide is equal to 0.52 mole per dm cube. Mole calculation is difficult to many candidates. You have to follow some tips and hacks I have used already. Very simple problem I have discussed. If you have more questions regarding mole, you can write in the comment below. I think you can get the correct answer. If you get a very little benefit from this video, please subscribe this channel and share with your friends. Thank you very much for watching this video.